Let's take a look about another way we can measure angles, and that is in radians. If you watched the previous video, that was the angles measured in degrees. Now we can measure the angles in radians. And radians really are based on the circle, where we form a central angle where the vertex is in the center of a circle, and we have a certain radius that is exactly the same measurement as the arc length. This is our what is called arc length. In trigonometry, we abbreviate this with an S. So if R is equal to S, then we form an angle called in radians, and we abbreviate it with RAD. So if we start here at 0 and we go one full revolution around the 0, what is the measurement in radians? Let me remind you, the formula for the circumference of the circle is 2 pi r. Now, in trigonometry, everything is based on the unit circle, and the unit circle has a radius of equal to 1. So if r is equal to 1, we get a circumference of 2 pi, and in trigonometry, we call this one full revolution. So if we go in the circle, same color, not good, but here we go. One time around the circle, of course, counterclockwise. If we started at 0, one full revolution is considered 2 pi. So 2 pi is the equivalent of 360 degrees. Now, if I divide 2 pi by 2, or multiply it by 1/2, what do I get? I end up at pi. So if I divide this into a coordinate system, I divide it by 2, I end up at pi. So pi is equivalent to 180 degrees. If I find 1/4 of 2 pi, reduce, that's pi over 2. So my angle, my 90-degree angle here is pi over 2, and here we have 3 pi over 2. So our angles on the axis, we start at 0, we go pi over 2, pi, 3 pi over 2, and we end up at 2 pi. Now over here, I basically drew my unit circle with all the common angles that we use in trigonometry. Now in degrees, we have the common angles of 30, 45, and 60 degrees. Equivalent to radian degrees would be pi over 6. Now I have it in this sequence, so I'm going to write pi over 3 for 60 degrees, and 45 degrees is pi over 4. Now, what is the conversion from degrees to radians? Let me show you. I claim that 30 degrees is pi over 6. So the conversion rate, what I need to do is I need to multiply it by pi over 180 degrees. I have to cancel out or reduce my degrees. So my degrees have to be in the denominator here with my conversion rate, which is pi divided by 180. Now I can reduce. 30 goes into 31s and into 186 times. So 30 degrees is pi over 6, just like I stated here. So the conversion from degree to radians, the conversion rate is pi divided by 180. So now let's go the other way. Let's say we have pi over 4, and I wish to convert that into degrees. So pi over 4, now what I need to think about is I need to reduce my pi's So pi has to be in the denominator. And what is in the numerator? The 180 degrees. I can reduce my pi's, and I can now reduce the 4 goes into 4 one time, and into 180 it goes 45 times. So the answer here, pi over 4, is 45 degrees. So my general conversion rate from radians to degrees is just the reciprocal is 180 divided by pi. So here I kind of drew the unit circle with all the radian measurements in each quadrant. 90 degrees is the equivalent of pi over 2. Now let's just take 1 radian degree in the second quadrant and let's convert it to degrees. I have a little room here. We have 3 pi over 4, and I want to know, okay, what is the degree value of that? I'm going to multiply by 180 divided by pi, so I can definitely go ahead and reduce the pi's. I can also say that 4 goes into 180 45 times, and then I have 3 times 45, which is 135 degrees. So the equivalent of 3 pi over 4 is 135 degrees. Let's try one more. Let's say we have 300 degrees, and I want to change this into radians, times pi over 180. Now I can reduce, first of all, the zeros, and we have 30 and 18. What goes into 30 and 18? What can I factor out? I can factor out a 6. 6 goes into 35 times. 6 goes into 18 3 times. And we always want to keep our radian degree in terms of pi. So in this case, we have 5 pi over 3 radians. That's how you convert degrees into radians and radians into degrees.